Hello everyone, this is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph College of Arts and Science, Autonomous, Cuddalore. The topic we are going to discuss about general periodic properties. This is a modern periodic table. First, we are going to discuss about classification of elements. With the discovery of large number of elements, it became difficult to study elements individually. So, classification of elements was done to make the study easier. Mendeleev periodic table. Mendeleev's periodic table is based upon Mendeleev periodic law, which states the physical and chemical properties of element are a periodic function of their atomic masses. At the time of Mendeleev's, only 63 elements were known. This periodic table is divided into 7 horizontal rows are called periods and 8 vertical columns are called groups. 0 groups was added later on the modern modified periodic tables. Some important of the Mendeleev's periodic table. It explains the systematic study of elements, prediction of new elements and their properties. He left space for the elements yet to be discovered. Atomic mass corrections of doubtful elements on the basis of their expected positions and properties. Some demerits or defects in the Mendeleev's periodic table. Position of the hydrogen is not explained in the right manner. The next one is position of the isotopes. So Mendeleev's classifications is based on atomic weight. Isotopes would have to placed in different positions due to their atomic weights. For example, you take an hydrogen. So hydrogen exhibiting 3 isotopes, right? H1, H2, 1H1, 1H2, 1H3. But it is not explained in the right manner. Then third one is anomalous positions of some elements. So without any proper justifications, in some cases the element with higher atomic masses placed the element with the lower atomic masses. For example, you take an aluminum atomic weight is 39.9. The precedes potassium atomic weight is 39.1, whereas aluminum atomic number is 13, potassium is 19. See the difference. Similarly, cobalt and nickel and position of the lanthanides actinides are not placed in the main periodic table. It is given separately. So modern periodic table is given in the year 1913 by Mosley. He started physical and chemical properties of element or are the periodic functions of their atomic numbers. It is known modern periodic law, considered as the basis of the modern periodic table. When the elements were arranged in the increasing order of atomic numbers, it was observed the properties of elements were repeated after certain regular intervals like 2, 8, 8, 18, 18, 32. These numbers are called magic numbers. Some structural features of long form of periodic table. So long form of periodic table is called Bohr's periodic table. So it contains 18 groups and 7 periods. The horizontal rows are called periods. Totally 7 periods. The first periods containing hydrogen and helium. That are totally 2 elements. The second period is lithium to neon. Totally 8 elements. Then third one is sodium to argon. So again 8. Then fourth one is potassium to krypton. So totally 18 elements. And fifth one is rubidium to xenon, and sixth one is cesium to radon. Then finally the sixth group containing 32 elements in the period is the longest period. Then seventh period is starting with francium, is incomplete and consists of 19 elements. S black elements. S black element in which last electron entered the s orbital of their respective outermost shell are called S black element. S subshell has only one orbit which can accommodate 2 electrons. Therefore, it divided into 2 groups, S group. One is called alkali metal, another one is called alkaline earth metals. So alkali earth metals contains lithium, sodium, potassium, rubidium, cesium and francium. And alkaline earth metal is beryllium, magnesium, calcium, strontium, barium, radium, like that. There are totally 14 S black elements in the periodic table. Some special characteristics of S black element: they are soft metal with low melting and boiling point. They have low ionization enthalpies and are highly electropositive in nature. They lose the electron readily to +1 to +2 states. If you take an alkali metal, it exhibiting +1. If you take alkaline earth metal, it exhibiting +2. They are very reactive metals. The compounds of S black elements, with the exception of beryllium, are predominantly ionic in nature. Most of the metal of this characteristics color in flame. So all the most of the S black elements given in the color the flame. They are strong reducing agent. So they are all formed hydrates. So hydrates are strong reducing agents. Sodium hydride, lithium hydrides, sodium borohydride, lithium aluminum hydride. So these are all strong reducing agents. Also good conductors of electricity and heat. So B black element, like that. So B black elements also there will be 3 subshells or 3 degenerates p orbital. Each one can accommodate 2 electrons, totally 6. That's why the B black elements contain 6 groups, namely 13 group, 14, 15, 16, 17 and 18. The 18 groups are called noble gases, and the 17th group are called chalcogens, and the 16 groups are called niktogens, like that the names are called. Some special characteristics of B black element. So B black elements include both metals and non-metals. So it contains their ionization enthalpy are relatively high as compared to the S black elements. They are mostly covalent in nature. Some of them are shown more than one oxidation states. So possibly, if you take in the 13th group, boron, aluminum, gallium, indium, thallium, it exhibiting 2 types of oxidation states. If +1 also possible and +3 also possible. Like that, the carbon group is +2, +4. If size is increases, the low oxidation states is more stable. For example, just consider the boron family. Boron is exhibiting +1 and +3, but the boron +3 is more stable. In the case of thallium is +1 more stable, because of inert pair effect. Next, D black elements. Elements which the last electron enter any one of the 5 d orbitals of their respective penultimate shells are called D black elements. It has 5 subshells, so each one can accommodate 2 electrons, totally 10. So D black elements contains 10 groups, 3, 4, 5, 6, 7, 8, 9 to 11 and 12. They are hard, malleable and ductile metals, and also high melting and boiling points. So the D black elements having lot of special characters it exhibiting. Also it exhibiting the various oxidation states. They are good conductors, heat and electricity, and their ionization enthalpy between S black and B black, so comparably high. They show variable oxidation states, I already told. Generally colored, the D black elements are colored and paramagnetic in nature. Most of the transition metals such as vanadium, chromium, manganese, cobalt, iron, nickel, copper and their compounds are used as catalysts. So usually for synthesizing carbon, for making carbon-carbon bond, these catalysts were used. Next one, S black elements. The elements which the differentiating electron enters into n minus 2 f orbitals are called f-black elements. So totally 7 subshells are there. Each one can accommodate 2 electrons. So totally 14 groups are there. That's why it contains 14. So one is called lanthanides, another one is called actinides. It's a lanthanide series and the actinide series. So end with it starts with end with 103. Some special characters of F-black elements, they are called heavy metals, or otherwise called rare earth metals, or called radioactive elements. They have high melting and boiling point. It is also show variable oxidation states. Their compounds are generally colored. They have high tendency to form complexes. Most of the actinides are radioactive in nature. So these are the general periodic trends: ionization energy, electronegativity, metallic character, non-metallic character, so atomic radius, electronegativity. So these are the general representations. Thank you.